This is exam 2, Physics 102, spring 2013. What is the equivalent resistance of this circuit? Start with this part of the circuit. That's 1 over 1 over 2 plus 1 over 2, and that's equal to 1 ohm. And so I can replace these two with a 1 ohm resistor, and then I'm left with a 1 and a 4 ohm, and that's going to be a 5 ohm resistor. That's 1 plus 4 equals 5, and that's in parallel with a 5 ohm resistor. So I have 1 over 5 plus 1 over 5. It's 1 over 2/5, which is 5 over 2. That's 2.5, so the right answer is C for number 1. For the previous question, if this EMF is 10 volts, what is the voltage across the 4 ohm resistor? So I know that I have 10 volts here, and then 10 volts across this branch up here. So I have 10 volts there. And that the equivalent of that top branch is 5 ohms. So that means that I have 2 amps. Let me redraw it over here. You'll see it more easily. So I can redraw this circuit as a 1 ohm and a 4 ohm in parallel with a 5 ohm. I'm telling you that it's now hooked up to a 10 volt power supply. This is 5 ohms. I know that this top branch has 10 volts across them combined, and that means that my current coming here, I, is equal to V over R. That's going to be 10 volts over 5 ohms, which is the equivalent of that 1 and 4. So that's 2 amps. So I have 2 amps coming through this branch of the circuit, and then I can find my voltage here, because I have 2 amps going there, and 2 amps going through the 4 ohm resistor. So V is I times R. That's 2 amps. That's 4 ohms. That's 8 volts. So for number 2, the answer is A. Which of these following equations for this circuit is correct? I'm going to start with this first one, 4 minus 2I1. This is my only 4-volt battery. I'm starting, going in this direction, minus 2I1. So far that's okay. I'm going with the current, so it's negative. Minus 12, that's correct. Minus 3I3. That's not correct because it should be positive 3I3 since I'm going against the current. Minus 4 minus 2I2. That means I'm going in this direction. There is no 2 ohm resistor. It's just this one, which is not I2, it's I1, so that's not right either. There's several problems with that. Let's see, C is minus I1 plus 5. Oh, wait, no, excuse me. Sorry, I made a mistake here. I thought that said I1. It doesn't. It says I2. So for this one, it should be minus 4. So I'm going in this direction across that battery. Minus I2. So I'm following along here, and it's going to be going through this resistor, minus 1 times I2. Plus 5 plus 2I1. And it is positive because I'm going against the current. So the right answer here should be B. And C doesn't work out to be right either. Let's see. So for C, I have minus I1 plus 5 minus I1. There is no current. There is no resistor with a value of 1 ohm in the branch that has 1 I1, so that can't be the case. This can't be true. And then I1 plus I3 equals I2. I just take a junction. My incoming currents, well, they're all incoming. So the junction rule would say I1 plus I2 plus I3 equals 0. Now consider the above circuit. If I3 is equal to 2 amps, so that's this current, I3 equals 2 amps. What is the magnitude and direction of I2? I'm going to start here. I'll go in this direction, writing the loop rule. That's minus 3 times I3 plus 12 minus 5 plus 1 I2. That's equal to 0. I want to find I2. This is minus 3 times 2, which is minus 6, plus 12 minus 5 equals negative 1 I2. 12 minus 6 is 6 minus 5, so 1 is equal to negative 1 I2. So I2 equals negative 1. All right, so it has to be 1 amp. I2 is initially given as down. That means it has to be up because it's negative. So the answer is B for number 4. Which of these statements about a household circuit is true? A household circuit is a series circuit. That's not true. It's a parallel circuit. All devices operate at the same current. That's not true. They all operate at the same voltage. It's parallel. As you add more devices to a household circuit, the total current increases. Okay, that is true. And the GFCI turns off if IN is greater than I out. And that is true as well. So 3 and 4 are the right answers. A. The wires in this junction have the currents as labeled. What is the unknown current? All right, so I have 7 and 3 coming in here. So that means that I have 10 amps going in this direction. And then I have 2 amps coming in. So that means I have 10 plus 2 or 12 amps. So the answer is B. For number 6, if the switch S is closed, what happens to the potential across R1? So if I close the switch like that, and I add R3, that means that the resistance of this whole branch, the equivalent resistance, will go down. That means that the voltage goes down, and if that voltage goes down, then V1 has to go up in order to keep the same, because they all have to add up to get the EMF of the battery. So it should be B, increases. 2 resistors are connected in series with an 18-volt battery. Like that. One of the resistors has a potential of 6 volts. What's the potential across the other? They have to add up to give 18, so it has to be 12. D. What's the purpose of the third prong on a 3-prong outlet? Not stability. It does have a purpose. Not an alternative. It acts as a ground, providing an alternate path for electricity to flow. In a single circuit within your house, what happens to the total resistance as you add electrical appliances? This is a parallel circuit. As you add resistors in parallel, the resistance decreases. That's B. How are natural magnets created? It's not iron mixes with magnetic particles, not dinosaurs, that's oil. Molten metal solidifies in the presence of a magnetic field, so it's C. And it's not high pressure and temperature, and that's rocks, right? Which of these statements is true? Opposite poles of a magnet attract. That's true. Magnetic monopoles do not exist. That's also true. All permanent magnets are ferromagnetic. That's true. Not all ferromagnetic materials are permanent magnets, but it is true that all permanent magnets are able to be magnetized, and so they're ferromagnetic. So D is the answer for number 12. The Earth's magnetic field plays a role in which of these atmospheric phenomena? Remember, here's the Earth, has these magnetic fields. These high energy particles come streaming from the sun, and they are brought up into the Earth's magnetic field, and then they create the aurora borealis at the poles. So that's A is 13. Negatively charged particle enters magnetic field as shown. Was a force acting on the particle? Okay, well, let your fingers go in the direction of V. B is into the page. And that gives you, the right-hand rule gives you a force that's up, but notice that it's a negative particle, so the force is down. 14 is C. I pass a wire through a magnetic field as shown. The wire is length 2 meters. Magnetic field is 8 Tesla. The force you apply is 32 newtons. What is the current in the wire? This is like a generator. I'm forcing this wire through a magnetic field. All right, my F is given as ILB, and I want to find what is my current. That's F over LB. That's going to be 32 newtons over L times B. That's 2 meters times 8 Tesla. 32 over 16 is 2 amps. Right, so the answer is D for number 15. And what's the direction of the current? Okay, well, Uh, I let my fingers go in the direction of my velocity. So I'm pushing it down in this direction. Uh, and the magnetic field is out of the page, so that means it's going to be to the left. Is that right? Yeah, to the left. So it's C. Number 16 is C. Coil of copper wire, which is allowed to rotate about the axis shown with a dashed line, has a current going through it as shown. What is the initial direction of rotation for the coil? So my current is in that direction. So the force on this side is going to be up, and that will cause a clockwise rotation. The force on this side will be down. So it's B for number 17. This figure shows the path of a charged particle. What is the charge of the particle? Use your right-hand rule to determine the force on this particle, and you find that the force is up. All right, the force on a positively charged particle would be up. Excuse me, no, that's not correct. The magnetic field is out of the page, so the force for a positively charged particle would be down. However, we do see that the force is up because of the path that it takes, and so that means it has to be a negative particle. So number 18 is B. Okay, mass spectrometer has these quantities. Want to find this particle. R is mv over q b. I'm going to solve for m over q. That's rb over v. If you do that, you find that it's 0.052 meters. Magnetic field is 0.4 over v, which is 2 times 10 to the 6. (1.04 times 10 to the minus 8). That's my mass to charge ratio. And then I go through and I divide the mass by the charge. But since it's so close to 1, it has to be this one. 1.67 divided by 1.6. That is hydrogen. So 19 is D. Speed of light in a vacuum is 3 times 10 to the 8th. Index of fraction is 1.5. What is the speed of light? So V is C over N. Two times 10 to the 8th meters per second. That's B. Isaac Newton believed light was a particle, and he believed it was a particle because of reflection. That's D. It's 21. Light is incident on a glass plane mirror. Incident angle is 20 degrees. I want to know what is the reflected angle. It's just exactly the same, 20 degrees. So the answer for 22 is C. Interference is a phenomenon that's viewed only in waves, and this is version A.